Good morning. Today we're going to look at a case where we have an object that's moving across a level surface, but the force applied to it is not an upward pulling force, but a downward pushing force. And so here we have someone who is leaning over on top of the box and pushing the box, but at a downward angle rather than an upward angle. So let's say that we have a box of books weighing 325 newtons that moves with a constant velocity across the floor when it is being pushed with a force of 425 newtons exerted downward at an angle of 35 degrees below the horizontal. And we want to find mu k between the box and the floor. Alright, so let's write down a few givens. First of all, it's important to notice that they did not give us the mass, they gave us the weight. And the only way that we know that is by knowing the units. It says a box of books, a 325 Newton box of books. And so Fg, the weight of it, is 325 newtons. I've actually put that where it's going to be difficult to draw a free body diagram in a moment. So let's move that while it's still early. So Fg equals 325 newtons. Alright, so Fg is 325 newtons. It moves with a constant velocity. If it has a constant velocity, then we know that the acceleration is 0 meters per second squared. And we also know that there is no net force. And so the words constant velocity are very important. Constant velocity across the floor when it is pushed with a force of 425 newtons downward. So here's our applied force, and it is equal to 425 newtons downwards at an angle of 35 degrees below the horizontal. So that means that from the horizontal downward is 35 degrees. And it says find mu k. Alright, so mu k equals question mark. Alright, so now we've got that set up. First thing, let's go ahead and draw a free body diagram. Let's add on here the force due to gravity, straight down. The normal force, which will be upwards. We've already got Fa. We'll break it into components in just a moment. And since it is being pushed in a way that's going to slide it forward this way, we will actually have Fs acting backwards in this direction. Alright, so let's see, quick little label. Fg, Fn, Ff, and let's go ahead and break into components our angled force here. And so we'll have Fay and Fax. Alright, there we go. I guess I should say we'll have Fax and Fay. Alright. At this point, we can go ahead and begin writing down relationships between the forces. Now let's see. We know that its acceleration is 0, so all the forces in every dimension are going to be balanced. So our downward forces will balance our upward forces, and our leftward forces will balance our rightward forces. Okay, so let's see. First of all, I'm just going to go ahead and write down what's likely to be our finish line since we're looking for mu k. We know that it's equal to Fs over Fn. So those are the two things that we'll need in order to solve the problem. Let's see. Let's do the y dimension first, and that means that our downward forces, Fg, and here's the tricky part. Since this is pushing downwards, Fay is also acting downwards. So Fg plus Fay together will equal Fn. So Fn is actually going to be larger than Fg in this case. In the x dimension, we have, have FF and FAX, and those are the only two, so they will be equal to each other. FF equals FAX. No point in writing FNet equals MA since A is 0. That'll be 0 and 0. And let's see if we have everything that we need except for, and no real point to writing FG equals MG either, because we don't need the mass since we're not going to use FNet equals MA. All right, now one thing that we do need to do is break our applied force into components. So FA sine theta will equal, there's our theta. FA sine theta will equal the opposite side, which will be FAY. And we'll get a value for it in just a moment. And then FA cosine theta will equal FAX. All right, so let's pause for just a moment and calculate those values. All right, and I did the calculations and came up with that FAY was equal to 243.77 and FAX was equal to 348.14. So what we'll do next is we'll put both of those. Now let's see, FF is equal to FAX, so we know that FF is going to equal 348.14, and so that's going to be one of the numbers that we'll need over here. UK equals, and we'll have 348.14. And now let's see here, we have 325, and that is not a mass, that is the weight. They gave us that value in newtons, and so we do not need to do anything else to that except plug it in for FG, plus 243.77, and that will equal Fn. And when we do the math on that, we find that Fn is equal to 568.77. And so we'll write that in here for Fn, 568.77. At this point, all that's left to do is the division. And when we do, we find that mu k is equal to 0.61. That is a rounded value. If I were putting that in for my homework, I would carry it out 2 more spots to be sure I didn't lose points for early rounding. But for our work here on the screen today, 0.61 will do nicely. All right, I hope that was helpful, and have a great day.